Navarro, buen día. I joined the University of Luxembourg a year ago, and I'm here today to briefly introduce my research project. Fundamentally, on my research project, I'm retrieving altimetry over polar and ice-covered regions to better know the sea ice topography, because the sea ice distribution is a global climate change indicator. There is an existing system to retrieve sea altimetry, which are satellite-based radar altimeters, but they have some limitation. Their low temporal and spatial resolution because of their repetitive orbits. They don't have coverage in Arctic and Antarctic region, and also the high cost missions. Here we can see an example of one of these type of satellites, JSON-3, and here we can see the 10 days coverage for this type of satellite. Also, as we can see, there is no coverage on the polar regions, as we mentioned before. On the other hand, we have the method used for my PhD, which offers an excellent opportunity for its high temporal spatial resolution, their worldwide coverage, and the low-cost satellites used for this technology. On the right, we can see one-day coverage using GNSS-R technology, which comparing with 10 days of the satellite-based radar altimeters, it's quite a lot. But what's this GNSS-R technology? GNSS reflectometry is the study of the signals of opportunity, which are fundamentally the reflected signal of the GPS reflected to the surface of the Earth and then collected to another platform, which in my case of study is a low Earth orbit satellite from Spire Global company. Spire Global has more than 25 satellites around the globe designated for that platform, which give us, as we mentioned before, high temporal and spatial resolution. The altimetry retrievals using this method mainly relies on the differences of the reflected signal and the direct signal from the GPS. Jumping to the results, I wanted to show you the preliminary results obtained in Hudson Bay, Canada, as we choose this area to validate our software and using this region as a starting point before jumping to Antarctica or Greenland, so to say. I choose 3 months data in Hudson Bay as a very suitable and steady area because of their 92% of their water surface has almost ice constant surface from January to March. So I decided to choose January to March period 2021 as a starting point from my research project. Millions of reflections have been processed. Here we can see one track example. And additionally to the outcome mentioned before, we wanted to provide the sea surface map of Hudson Bay. In terms of quality check, our solution is in agreement close to 16 centimeters compared with the existing models. These results were worth for a paper, so we decided to submit it in the IEEE International Geoscience and Remote Sensing Symposium for this year. As to conclude, I will continue my research to improve the results and also start to analyze polar regions and to try to reach a centimeter level as the radar altimeters do right now. Like this and continuing like this, we will try to contribute to the estimates of the climate change. Thank you very much for your attention and your time. Now I would be very happy to answer your question if there is some. Thank you.